quadratic equations, their roots, using the sum and product of roots, and solving questions that relate with them. Now, what is the quadratic equation? Equation is in the form of ax plus bx plus c equals to 0. So that means in this case, we can equate this is our a, this is our b, and this is our c. So these are examples of quadratic equations. You can see question 2, 4 over 5x squared minus 3 over 10x and minus 5 over 21. So in this case, a is this is b, and this is c. Just like this is a, b, and c. So these are not quadratic equation. You can see in this case, this is not quadratic equation because your x squared is inverse 1 over x squared. So when you see something like this, that's not a quadratic equation. Also, we have what we call the discriminates from a quadratic formula when we have x equals to minus b plus or minus square root of b squared minus 4ac all over 2a. So these are discriminates. So when the discriminant is greater than 0, that means the roots are real. But when it is less than 0, the roots are complex or imaginary. So we have what we call imaginary roots. Now we're looking at the sum and product of roots. So when we have a quadratic equation in the form of ax squared plus bx plus c equals to 0, let the roots be alpha and beta. That means the two roots will be alpha and beta. So this means the sum of roots a plus b, alpha plus beta equals to minus b over a, and alpha beta equals to c over a. There are so many ways of getting this, but let's look at, for example, from two roots when we have the first one is alpha, that is x1 is alpha, and the second root is beta. So if you take it back, if you go and try to reverse all what we did to get this answer, so this is also going to give us x minus beta equals to 0. So you can actually write it back like this: x minus alpha, then x minus beta equals to 0. Then we can expand. That means x into x minus beta minus alpha equals to x minus beta equals to what? 0. This is going to give us x squared minus beta x minus alpha x plus alpha beta equals to 0. So what we have, this is common, minus is common there, and both of them have x. So you can bring it as minus. Let's bring the x here. What will remain is beta plus alpha beta equals to 0. So you can just write it this way. Write our alpha first, beta, then put our x here, plus alpha beta equals to 0. So if you compare it to what we have earlier, when we have, if you compare it to this, when we have x alpha ax squared plus bx plus c equals to 0, you discover that if you are divided by a all through, let me just write them down: x squared plus bx over a plus c over a equals to 0. When you compare it, let me just group them together. We have x squared minus alpha plus beta x plus alpha beta equals to 0. If you equate this, you discover that minus alpha plus beta equals to b over a. So if you divide both sides by minus 1, alpha plus beta becomes minus b over a. And if you compare these two parts also, you discover that alpha beta equals to what? C over a. Note all these things down. All right, let's take an example on this. So I won't make the video too long. Example: find the sum and products of roots of the following. So the first one is, let's have 21x squared minus 7x plus 7 equals to 0. And the second one is 6y squared plus 2y plus 3 equals to 0. So let's take it this way first of all. Okay, let's take one more question. Is 5 minus 10x minus 3x squared. So what we have to do, let's solve these questions. First one is 21x squared minus 7x plus 7. If you compare with this ax squared plus bx plus c all equals to 0, we discover that a equals to 21, then b is going to be minus 7, then c is 7. So we can now look for what? We can find our alpha plus beta. That is sum of roots is going to be, sum of root is minus b over a. So in this case, it's going to be minus 7 all over 21, which is 7 over 21. 7 can divide both 21 and 7. So that is 7 here is 1, 7 here is 3. So our sum of root is 1 over 3. Let's check our product of root, which is c over a. In this case, c is 7 and a is 21. So this is also going to give us 1 over 3. So the sum of roots and the product of roots here is 1 over 3. Now question 2b, we have 8x squared. No, sorry, we have 6y squared plus 2y plus 3 equals to 0. So in this case, a is 6, b is equals to 2, c equals to 3. So we can get our sum of roots. Sum of roots is equals to minus b over a. In this case, that is minus 2 all over 6. And this is going to give us minus 3, minus 1 over 3. Then we also have alpha beta, which is equals to what? That is c over a, which is 3 over 6, which gives us 1 over 2. So these are the sum and product of roots. Then we have another question that is 5 minus 10x. So let's do the third one. So we have 5 minus 10x minus 3x squared equals to 0. The coefficient of x is always, x squared is always our a. So this is minus 3. And what is our b? That's minus 10. And what is our c? That's 5. So what we have to do is this. Our formula, since we know that our sum of root is minus b over a, that means minus b is minus 10. So we write minus 10 all over minus 3. Minus times minus is going to give us plus, that is plus 10 all over minus 3. That means when we have plus over minus, it's going to be minus. So 10 over 3. Then the product is going to be c over a. What is c in this case? C is what? 5. And a is minus 3. So there's also plus here. And that means plus divided by minus is going to give us minus 5 over 3. So this is how we find the sum and product of roots. So see you next class. Bye.